Good afternoon, students. In the last class, we discussed about the catalysis and the types of catalyst and the types of catalyst. Okay. So in the today's class, we are going to discuss about the very important phenomenon that takes place in heterogeneous catalysis. That is what, as I told you, that is adsorption process. Adsorption in heterogeneous catalysis. Okay. So adsorption in heterogeneous catalysis. What is meant by adsorption? Means accumulation or accumulation of the adsorbents, adsorbents on the surface of the molecule. That is called as adsorption. So in the heterogeneous catalysis, how the adsorption takes place. I take the example of this, that is CH2 double bond CH2 in presence of H2 and nickel as the catalyst form platinum or palladium as a catalyst form CH3 single bond CH3. Understand? So this is the reaction and consider. So this one is assume. Okay, this is gaseous in state, solid in state, gaseous in state. Okay, so that means these two are different in phase. Okay, this is catalyst, this is solid phase. These two are called reactants, gaseous phase. This is the product, gaseous phase. That means what here? They are example for a heterogeneous catalysis. Understand? Here, how the reaction takes place. 5 steps are there in the adsorption process of catalysis. First one is diffusion of reactants on the surface of catalyst. On the surface. I just say on the surface. Next is diffusion of that on that surface. Catalyst surface. Okay. Next, adsorption of reactants. Adsorption of reactants or reactant molecules. Both. Next, third one is reaction between reacting molecules. Okay. Next, fourth one is desorption of products. Next, fifth, diffusion of products away from the surface. These are the 5 steps involved in adsorption of the catalysis. What it is? Diffusion of reactants on the surface. Next, adsorption of reactant molecules. Reaction between the reacting molecules. Desorption of the products. Diffusion of products away from the surface. So students, I'll explain the mechanism here, how it takes place. Listen here, platinum is the catalyst, hydrogen gas, and the ethene molecule is the gas. These two are the reactants and this one is the catalyst. So it is solid in state. Listen, this is the solid state. This is platinum, where it gives a surface for the molecules for adsorption. This is the surface of platinum available for the adsorption of the reactant molecules. Here the reactant molecules are what? One is hydrogen, another one is ethane. First one, what happens? Diffusion of reactants on the surface. Here H2 and ethene molecule come closer to here. They diffuse inside this. Okay, they diffuse near this platinum molecule. So then what happens? Adsorption of reactant molecules takes place. Initially, I'll take here, assume hydrogen is there. It is like this. Then what happens next step? This breaks the bond here and forms the bond here. Okay, this breaks the bond between here. One starts to bond here. Okay, next to this ethene molecule is added. Already here H is there. Here also H is there. To this ethene molecule is also added. CH2 double bond CH2. Understand? So students, next what happens? Here, listen, bond breaks here and bond formation takes place here. Or, listen, this reaction happens, this form activated complex, that is star. Okay, so this is high in energy. Then what happens? This will break the bond here. This will form the bond here. Understand? Then it forms similarly. This will form break the bond here. This will form the bond here. Means at the same time breaking of the bond takes place. So it will be like CH3, single bond CH3. Here it is the surface, then it is here. It will be like that. It is in unstable form because carbon has a capacity to form 4 bonds, but here are 5 bonds. 1, 2, 3, 4, 5. So there is a force of attraction between this catalyst and this. So listen, first one is diffusion of reactants on the surface. This is the diffusion. H2 is diffused, resistant, CH2 is diffused. Next, adsorption takes place. This is where on the surface exactly they absorb like this. So, like this. Next, reaction between reacting molecule takes place. Here the reaction between the reacting molecules takes place. Next, desorption of products. Desorption means here result. If it is like this, understand? Here, they are exactly near to each other. This bond will break. Force of attraction will break. That is called as what? Desorption. But they are exactly on the surface. Just above the surface. And the last one is diffusion of product away from the surface. Okay? The last step is diffusion of product away from the surface. Diffusion of product away from the surface, that is the answer. This reaction. CH2 plus H2, presence of platinum gives CH3, CH3. This is how the mechanism takes place. Initially what happens? Diffusion of reactants on the surface. They diffused here. Both the reactants H2 as well as CH2. Then the adsorption takes place on the surface here. Adsorption takes place. Next, the reacting between the reactants. The reaction between the reactants CH2 is the reactant and H2 is the reactant. They react with each other to form a product. But this product is adsorbed on the surface. So that's why here desorption of product takes place. Remove this adsorbed product from the surface. That is desorption. Removal process. Next layer, diffusion of product away from the. This is diffusion of product away from the surface. This is how the mechanism takes place. Understand? These are the 5 steps involved in absorption of the heterogeneous catalysis. They may ask only steps, not that mechanism. There are steps. Write the steps involved in adsorption of heterogeneous catalysis. So students, another one, features are there. Okay. Features of heterogeneous catalysis. Okay, so one is activity, another one is selectivity. One is activity, another one is selectivity. Okay, so students, what is activity means? So here, the ability of the catalyst ability of the ability of the catalyst to accelerate the rate of chemical reaction. Rate of chemical reaction is called as activity. The ability of the catalyst to accelerate the rate of chemical reaction. Understand? So here is a, so students, you know, almost the D block elements exhibit catalytic property. So group number 5 to group number 11 shows high activity or more active, shows catalytic activity. In the 5 to 11, group number 7 to 9 are highly active. So group number 7 to 9 are highly active. Understand? So that means iron, nickel, cobalt, they are often platinum, palladium, they are often used as catalysts because their activity is more compared to other transition elements. Understand? So next one, students, here what are the condition means? The adsorption, what is the reasons to show this activity means adsorption must be reasonably strong. Means the adsorption is only that much strong, how much it can easily adsorb, it easily dissolve. Listen, if the substrate is there, if the substrate means if any A molecule is there, the bond between these two is very high, means there is no possibility of taking place of any reaction. So if the adsorption process in the force between these two catalyst and the reactant molecule is very high, this is what adsorption must be reasonably strong. Only how much to attain the reaction, to conduct the reaction, only that much strong adsorption should be happen. If it is more than that, then the reaction cannot happen. If it is less than that, then also reaction cannot be happen. So it is reasonably strong. Okay, next another one is it must have a large surface area for adsorption. These are the conditions or reasons how the activity of this catalyst is. What is this activity means? The ability of the catalyst to accelerate the rate of the reaction. Active catalyst. Understand? So 5 to 11 shows the elements from the group here. Group 5 to 11 shows catalytic activity. In that 7 to 9 are highly active. And this one, the reason for that reasons this is. For this activity is absorption must be reasonably strong and it must have a large surface area for adsorption. So the next one is students, that is selectivity. What is this selectivity means? Okay, I'll give some reactions, then you came to know. For example, I'll take the reaction between CO and H2, carbon monoxide and H2. I'll give a set of reactions here. So listen, if this carbon monoxide combined with hydrogen in presence of nickel at 8. If nickel is a catalyst, in presence of nickel, if carbon monoxide gas and H2 is reacted, then they form CH4 plus H2O. Here it is metals. Okay, this is also gas, this is also gas, then we will liquid. Next, CO plus H2 in presence of copper as a catalyst. Okay, then it forms HCHO. Understand? Same, if CO is treated with H2 in presence of ZNO or Cr2O3 and it is heated, then it forms CH3OH. This is 2 times. Okay, so students here, what is the conclusion we drawn from these three reactions is both the reactants are CO only and all are gaseous only. All are gases only. This is also gas, this is liquid. Understand? From this reaction between CO and H2, three reactions are there. In both the three reactions, reactant molecule is same, but the product obtained is different. Here it is methane, here it is aldehyde, here it is alcohol. What is the reason for that reaction? This catalyst. Understand? So what is the selectivity of the catalyst means? The ability of the catalyst, right here. The ability of the catalyst to direct reactants to produce particular product. Is called as selectivity. Okay, the ability of the catalyst to direct reactants to produce particular product. So this is the example. Listen, here CO plus 3H2. If nickel is the catalyst, then this nickel is used to form this methane only. But this nickel cannot use to form this aldehyde. So if we want methane, then we have to choose, we have to select this nickel as a catalyst. If we want aldehyde, that is formaldehyde, then we have to choose copper, not this nickel. Nickel cannot give this aldehyde. So this is what the selectivity of the catalyst. For a particular compound, we have to use a particular catalyst. Means this nickel will be used means this nickel cannot be formed this aldehyde, and this aldehyde cannot be formed this methanol. If copper is used, it cannot form methanol. If ZNO is used, it cannot form methane. for a particular reaction, a particular catalyst is there. That is a selectivity of the catalyst. These are the two main features. Features means lakshana. The important thing is shape selectivity. Shape selectivity that is specially explained by enzymes. Okay, in this selectivity process, the main thing is shape selectivity. By particular shape, this catalyst or this catalyst or any other reactant molecule or any enzyme. Enzyme is also a biocatalyst. You know that the biomolecules I said to what is that, to break the molecule of maltose, to convert maltose into any other saccharides. Monosaccharides we use maltase. Sucrose to glucose and fructose means we need sucrase, invertase. So those are enzymes. Okay, so those enzymes are biocatalysts to conduct a biochemical process. Okay, certain reactions are there, enzymes are there. That enzymes shows shape selectivity of the catalyst. This selectivity, one of the most important is shape selectivity. How the mechanism takes place, I'll explain. Okay, so this is all about the features. So students, next one is shape selectivity. In that main electrode, one is zeolite, another one is enzymes. Enzymes strongly explains the shape selectivity. So in this shape selectivity, one is zeolite, another one is enzyme. So students, zeolites means, so those are aluminosilicates. Okay, understand? So that, okay. So this zeolites means, and right here, zeolites. These zeolites are aluminosilicates, consist of aluminium, silicon, and oxygen. Okay. So the structure of this aluminosilicate is, their structure is honeycomb pattern. Honeycomb means jane root ಇರ್ತದಲ್ವಾ ಅಂತ means ಯಾವ ತರ ಇರ್ತದೆ ಈ ತರ continuously joints ಇರುತ್ತೆ right here now this type of joints ಈ ತರ ಇರುತ್ತಲ್ವಾ honeycomb jane root ಇರುತ್ತಲ್ವಾ means it is completely surrounded. In the center a vacant spaces are there like this in honeycomb jane root ನೋಡಿ ಅದನ್ನೆಲ್ಲ ಕಂಪ್ಲೀಟ್ ಹುಳಗಳೆಲ್ಲ ಎದುರುವಾಗ ಆ ಟೈಮಲ್ಲಿ ನಿಮಗೆ ಈ ಥರ ಗ್ಯಾಪ್ ಕಾಣಿಸುತ್ತೆ. Okay, that is called a shape in which the geolite shows that type of shapes. Understand? These are the catalysts that forms a structure like honeycomb. There is a vacant space. Understand? So those vacant spaces are called as micropores. Okay, those vacant spaces are called as micropores. Pores means pore. So students here, in this micropores, a substrate molecule is trapped. Understand? Here the absorption shape selectivity means, for example, for this is a solid, any catalyst you assume, in this any gaseous molecule is absorbed. Then what happens? In the shape of this, the gaseous molecule is collected like this. Are you getting? They exactly arranged in such a way they completely fill the gap. The micropores are completely filled by the gaseous molecule. That is why the absorption takes place according to their shapes. If it is triangle, absorption is in triangle manner. If it is square, it is in square manner. A particular shape. Understand? So this is how the geolites, the shape selectivity explained by the geolites. So students, one of the key you have to remember is these are called as micropores aluminosilicates having the structure honeycomb type. Okay? So one of the important geolite is ZSM5. ZSM5 is the important geolite which is used in petrol industry. Okay, what is the function of this? The function of this is it converts directly alcohol to gasoline. Gasoline nothing but petrol. Okay, so this ZSM5, a geolite, is used in petrol industry to convert alcohols directly into gasoline. This is the catalyst. It is a very important question for 1 mark. What is the function of ZSM5? To convert alcohol into gasoline. Or name the geolite which is used to convert alcohol into gasoline. That is ZSM5. Okay. So alcohol is converted into what? When the catalyst ZSM is used. Okay. Then it is converted into gasoline. In these three, this type of variety of questions can be asked, and this is very, very important in all these aluminosilicate type compounds. Understand? So the next one is another one, enzymes. So students here, in the enzyme, I write certain reactions for that enzyme. So enzyme, as I told you, they are very small quantity. In a small quantity we require in our body. For every human being or any living being, a small quantity of enzymes are required to convert to break the big biomolecules. Understand? So example for that is sucrose is there. C12H22O11. This is second one. Enzymes. Okay, so this is a sucrose. Decomposes to what? Or undergoes hydrolysis. Water. In presence of sucrase enzyme. Sucrase is the enzyme. Form C6H12O6. Glucose and C6H12O6 fructose. Glucose and fructose. Next, similarly, maltose. Of maltose, you take starch. N times of C6 H not C6, H10 O5. Okay, 6 N times of C6H10O5. This is what? Starch. So to break this starch into the maltose, we have diastase. Diastase is the enzyme which converts starch into maltose. Maltose formula is C12 H22 11. That is N/2X. Or you simply take N times. Because we don't know what is N. Converts into what? Maltose. Okay, again consider this maltose C12 H22 O11 undergoes hydrolysis in the presence of maltase enzyme. In the presence of maltase enzyme gives a glucose, two molecules of glucose, C6H12O6. Understand? So students, you know urea. Urea means NHCO, NH type compound. If it is combined with H2O, combines with H2O, forms NH3. Form NH3 as well as CO. NH3 and CO. NH2CO, NH2 plus H2O gives rise to NH3 plus CO. So students, to convert this, we require an enzyme urinase. This is urea. Upon hydrolysis converted into ammonia and carbon dioxide. This is a fertilizer, you know, urea. That is, when rain will come, water droplets when you mix it with water molecule, it forms. That is, when rain will come, water droplets when you mix it with water molecule, it forms ammonia and as well as CO2. To this conversion, the enzyme required is urinase. They require in very small quantities. So students, because of the presence of these in the smaller quantities, these are enzymes are called as what? Biocatalysts. These are enzymes are called as what? Biocatalysts. Enzymes are called as biocatalysts. Understand? So, but these all reaction takes place in a particular selective mechanism that is called as shape selectivity mechanism by enzymes. Understand? These all reactions takes place in such a manner, especially a way that is what? That enzyme is there that creates some shape. Okay, to that shape, the incoming molecule, this substrate, will arrange. Then they form a reaction. I'll explain, then you'll came to know. Okay. Mechanism of enzyme catalysis. So students, two steps is there. In step 1, formation of the activated complex. For example, enzyme is there, reacts with substrate, form ES star. This is activated complex. Next, step 2. This activated complex decomposes to give enzyme as well as product. Enzyme as well as product. This is the reactant called as substrate and this is the product. And this enzyme is a catalyst used to form products. And at the end it is regenerated. Okay? So how the reaction takes place. So students listen. Here I will explain. Listen. This is the enzyme. This is the enzyme. This is the enzyme having this type of structure. Okay? Enzyme. Plus substrate is there. Okay? Substrate means this one, this incoming reactants. Okay? How they will form? Listen, this is the substrate here. That is incoming substrate. So students, when they make to react with this activated complex, then what it forms? It forms a shape. It forms a shape such a way this enzyme can easily fit here. It forms a shape in a such a way how this enzyme shape is there. Exactly they used to fuse together. Understand? Shape selectivity. This is the enzyme shape. This is the incoming substrate. When the substrate is made to react with this enzyme, it forms a site. This forms a shape such a way that which is exactly the shape of the enzyme. This is called as active center. Active center means where this enzyme can easily attach. Okay, this may consist of a functional groups like NH2, COOH, etc. CHO, C double bond O, etc. Any. They consist of specially a functional groups. Understand? So then what happens? These together combine together form ESC star. Correct? So this is the reaction takes place. How they will form? So listen. Combine together form ESC star. Correct? So this is the reaction takes place. How they will form? So listen. This is the substrate here. Correct? So this is the enzyme. It exactly fits here like this. Understand? This enzyme exactly fit at the shape of the substrate form ES star. This is a active complex. Understand? It is exactly look like a key lock structure. Lock, you know that? Key and lock marker. Exactly like a lock. Okay? So the next one is the decomposes. Again, the third step is what? Second step is the decomposes. This activated complex decomposes to give enzyme as well as product. So students, next what happens? This enzyme made to react with this reactant molecule and it breaks. Okay? Then they form. This is generated again as it is. Okay, enzyme is generated as it is, and this reactant is break and form products. These products in the firm, if it breaks here, reactor may be like this. Products. These products in the firm, if it breaks here, reactor may be like this. They form products. This is how the mechanism takes place. Initially, this enzyme, why it is called as shape selectivity? Because they form a shape, the active centers in a such a way that the shape of the enzymes. Enzyme shape ಯಾವ ತರ ಇರುತ್ತೋ ಅದೇ ತರನೇ substrates ತಮ್ಮ shape ಅನ್ನು rearrange ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಅವಾಗ ಏನಾಗುತ್ತೆ? ಆಕ್ಟಿವ್ ಸೈಟ್ ಇಲ್ಲಿ ಮಾತ್ರ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. These are called as active centers where the space is available for the adsorption of this enzyme. Then what happens? They fuse together to form ES system. That is activated complex. And the reaction takes place and the enzyme, as it is a catalyst, it is regenerated and they form products. This is the mechanism. Understand? So students, what is the characteristics of this enzyme catalysis? The characteristics of enzyme catalysis. Okay, so the first one is they are most characteristics of enzyme catalysis. So students, in that the first one is they are most highly efficient. First one, they are highly efficient. Second one, they are highly specific in nature. Highly specific in nature. They are active only at optimum temperature. They are active only at optimum temperature. Next, they are also active only at optimum pH. Optimum pH. Okay. Next, they increases activity in presence of coenzyme. In presence of coenzymes. They increases activity in presence of coenzymes. So students, listen, the active only at the optimum temperature means for any enzyme, if a particular temperature is there, then it is active only at the particular temperature. Okay, if the temperature is below that or above that, it won't act, it won't react. Understand? Next, they are at the optimum pH of 5 to 7. Okay, if the pH is below 5, acidic, then also they won't react. If it is greater than 7, that is basic, then also they won't react. So they are highly specific in their activity. Understand? So this is all about the shape selectivity of zeolites and enzymes. So this is all about the shape selectivity of zeolites and enzymes and its mechanism. This mechanism is very important for 2 marks. Okay, so this is all about catalysis. This completes the second feature of surface chemistry. First one is adsorption, second one is catalysis. In the tomorrow's class, we will discuss the third feature, that is colloids. Okay, thank you.